Hello students, this is lesson U1A04a. In this lesson I am going to go over exercise U1A04a where we are going to attempt to try and factor expressions, try to factor binomials, trinomials, polynomials, and we're going to approach this, the skill needed in this exercise will be knowing how to identify the greatest common factor, as well as some factoring tricks involving factoring binomials and trinomials. So let's take a look. So let's take a look at the very first example here. Let's take a look at number 2. And immediately I see here that this is a binomial, okay? And what we're going to try to look for, as the instruction here is suggesting, says factor the common factor out of each expression. The instruction here failed to also mention that when you're looking for the common factor, you're looking for the greatest common factor. So let's take a look. I see here that I have the number 18, I have the number 2 there. The greatest common factor between 18 and 2 is in fact 2. Then I have these other variables at play here. So looking at this, I have n cubed, I have n squared, I have an m here and an n there. The greatest common factor, okay, that is going to be divisible into both of these terms, okay, in fact will be 2mn, because if I were to take 2mn and factor this, I'll end up with 2mn times, right, what's inside here, you got to think about the following. How many times does 2mn divide evenly into 18m cubed times n squared? Well, 2 goes into 18 9 times. M, okay, when divided by m cubed, right, m, when divided into m cubed, I'm going to be left with m squared. If I'm dividing n into n squared, I'll be left with n. The last term that I end up with, okay, well, how many times does 2m divide into 2? How many times does 2mn divide into 2mn? Well, that's just 1. So again, alternatively, okay, you can also think of, like, is there a common factor that can divide evenly into both of these things? And to answer that question, the answer is yes, of course. The answer is, if I divide 2mn, okay, into both terms in the numerator, this is the result that I get. But again, I am not just dividing something for the sake of dividing. I cannot just, that would change the original expression, so I gotta then multiply that on the outside here, right? So by doing this, okay, 2mn over 2mn, I will not change the original expression. I am preserving that original quantity, okay? And this is what I end up with. Again, this 2mn divided into 18m cubed n squared, this is what I'm going to be left with. Similarly, if I divide 2mn into 2mn, this is what I'm going to be left with, that 1. Alright, so let's try the next one here. Question number 4, same idea, okay? Is there a common factor that can be divisible into every one of these? And if you look at this, okay, each one of these things will be divisible by 7, because 28, 63, and 7 are all divisible by 7. Is there another variable that it's all divisible by? Divisible by. Right. So it will be divisible by a, right? Because all you got to do, right, is look for the variable with the lowest exponent here, and that's pretty much the trick, if you want to call it that, right? 7a, okay? Is every term divisible by a b? It doesn't appear to be so. There's no b here and no b there, so that's not a common factor. So because of that, okay, 7a is the greatest common factor. So actually, this is illegal, right, in mathematics. So what we're doing is, okay, we are actually multiplying by 7a over 7a if we want to think about it like that. Or we're factoring 7a, right? If we factor out 7a, right? Let's take 7a and divide it into 28a squared b squared. What will we end up with then? We'll end up with 4, right? 7 divided into 28, or 28 divided by 7. A squared divided by a, I'll end up with just a. B squared divided by a, right? Well, I'm sorry, we're not dividing b squared by a because we've already divided that factor in. So that's just b squared. And then I have 63 divided by 7, right? So that's 9. And then how many times is a cubed over a? What will that become? I'm left with a squared. And then lastly, 7a over 7a, that's just plus 1. Let's take a look at the next one. Okay, so these problems are getting lengthier and lengthier, right? But don't be afraid of that. It's all good, right? Let's take a look. Is there a common factor that we can divide evenly amongst every term in this huge expression, in this 4-term polynomial? Well, looking at this, I see 24, 64, 32, 32. It looks like 8 is going to be the GCF, right? Or at least the coefficient GCF. And then I look at this, okay? I see I have x to the 5th, y to the 4th. And then I have x to the 5th, y to the 3rd. X squared, y to the 3rd. X and y to the 3rd. If you want to call it a trick, right? The greatest common factor, what you're going to do is you're going to look for the smallest, you're going to look for the x with the smallest exponent, right? And that's this guy right here, right? So that's going to be a factor amongst every single term. And then you're going to look for the smallest, you're going to look for the variable y with the smallest exponent. So it looks like I have y to the 4th, y to the 3rd, y to the y, and y to the 3rd. It looks like y to the 3rd is going to be the largest one that's going to fit into every single term, right? So therefore, 8xy to the 3rd is my GCF. So again, when I divide everything out, I'm going to have an 8xy to the 3rd on the outside. What will this all become? I'm going to be left with, just to make this look a little nicer, I'm going to be left with 8xy to the 3rd. So 8xy to the 3rd, let's see here, 24 divided by 8, that's 3. X to the 5th divided by x, that's x to the 4th. Notice I'm just subtracting the exponents. Y to the 4th divided by y to the 3rd, that's y to the 1st. And then moving on, I have plus 64 divided by 8, well, that's just 8. And then I have x to the 5th over x, well, that's just x to the 4th. And then y to the 3rd over y to the 3rd, well, that's just 1. So I don't need to multiply by 1 because anything times 1 is itself. And then moving on, plus, or actually minus, 32 over 8. 32 divided by 8, that's 4. X squared over x, that's x. Y to the 3rd over y to the 3rd, that's just 1. And then plus 32 over 8, that's just 4. X over x is 1. Y to the 3rd divided by y to the 3rd, that is again 1. So I'm left with just this expression below here. Let's try that again. Question number 8. So again, we're looking for a GCF, a common factor between 16, 4, 10, and 10. So I noticed that I have a couple of negatives here. The greatest common factor doesn't have to be negative, but if you see a common factor that is negative, you may factor that out, but I don't see that here. So the GCF, looking at this, okay, I have 16, 4, 10, and 10. The greatest common factor, just number-wise, it appears to be 2. Next, moving on, remember the trick, if you want to call it a trick, is there an x term that you see in common between every is there an x factor that's in common between every term in the numerator there? It doesn't appear to be so. So x is not going to be a part of the GCF. What about y's? There are y's in every single term. However, which Well, what quantity of y is it? Is it y to the second, y to the third, y to the fourth, or y to the sixth? It actually will be y to the second, right? Because we're looking for the smallest value of y that can, or the smallest one that appears here, because that can divide evenly into every single one of these terms. So y squared is definitely a term. What about z? Is there a z in every term? It doesn't appear to be so. So 2y squared is actually going to be the GCF. And we're going to multiply the numerator also by 2y squared, remember. Right? So what will result from this? I want to get 2y squared. And then inside the parentheses, what am I going to get? I have negative 16y squared x cubed z squared divided by 2y squared. So negative 16 divided by 2, that's negative 8. And then I have y squared divided by y squared. That's just 1, right? So the y squared goes away. And I'm left with x cubed z squared. Then plus, how many times does 4y cubed divide, how many times does 2y squared divide into 4y cubed? So that turns into 2y, right? And then plus, I have 10 divided by 2. That's just 5. And I have y to the fourth over y squared. That's y squared. And I'm left with x and z. And then finally, minus 10 divided by 2. That's 5. And then I have y to the 6 over y to the second. That's y to the fourth. And then I have x squared. So this is going to be the factored form. I know this looks very intimidating, but I promise you all these problems are very similar in nature. So, and then we move on to the next one here. Again, we're looking for a GCF. Okay, so the GCF here is going to be, let's see, we're looking for a number that divides evenly into each one of these, right? So that would be, what would that be? That would be 3, right? 27 divided by 3. 3 can divide evenly into 27 and into every single one of these. There's a number 6 can divide into 12, but it doesn't divide into 27. 6 can also divide evenly into 30 and 18, but not into 27. All right, and then we're going to look for the variable here. I see I have x's in every single one of these, so definitely x is going to be a part of the GCF. What about z's? Z's. Z squared appears to be something that can divide evenly into every single term. And what about y's? Doesn't appear that way. So 3x z squared is going to be the GCF. So what will be the result of this? The result of this will be 3x z squared. Okay, so now I want to divide 3x z squared into negative 27x z to the 7th. And I'm going to be left with negative 9. X over x is 1. Z to the 7th divided by z squared. That's just z to the 5th. And then I want to do it again with the next term. I have 30 over 3. Well, that's just 10. X to the 4th over x. That's x to the 3rd. Z. Next, I have plus 18 over 3. That's 6. X squared over x. That's just x. Z squared over z squared. Well, that's just 1. And then y. I'm left with just y. And then plus 12 over 3, that's 4. X over x, that's just 1. Z squared over z squared, that's just 1 again. So this is the final expression for factoring the GCF.